If we're talking about planes, we talked about how you can take points and line them up and create a line. That if you take those lines and you line those lines up, you create a plane. Don't know why I didn't think of Lego before, but there it is. Points make lines, arrays of lines make planes. What we're going to do is we're going to use a couple planes here. Very nice little planes. Now, you'll notice the planes have two dimensions. They have length and they have width, but they have no height for our purposes. So we have length, we have width. Now, I have them all currently sitting on the piece of paper, which means that all three of what would be considered planes are indeed coplanar. Now, there's a little bit of a problem with using Legos to represent planes. Technically, remember, a plane goes on in each direction forever and ever and ever. So this would be like an infinitely large Lego mat. But the idea is if I take one Lego mat and I place another plane on top of it, and I actually lock them in, those two planes are now coplanar. So we have this idea of coplanar. Just like with collinear, collinear meant on the same line. Coplanar means on the same or with the same plane. Okay, so I have two planes on the same plane. If I take another plane and I lock it in again, that's also now coplanar because they are all on the same plane. Now, I can do it with points as well. So let's take a look at this plane right here. This plane right here, I can put point A on this plane. So that's going to be point A. I can take point B and I can put point B on this plane. Now, one of the first theorems that we're going to have is the fact that through any 2 points, there is exactly one line. I can always connect the dots with those 2 points, and they are always going to be on the same line, and they are always going to be collinear because they're always on the same line. However, if I put a third point in, now if I put it here, that point looks to be collinear because it would be on the same line. However, if I move that point here, that is no longer collinear, but they do remain because they're on the same plane, coplanar. So we have each of these key points, and they are coplanar. If I wish to, I could put these out at the edges, and now I have A, B, C, and I have plane A, B, C. By the way, it could be C, B, A, C, B. Doesn't make any difference whatsoever because they're all three on the plane, so it doesn't matter. Now, if on the other hand, I take another plane, and instead of laying it in the same plane, I move it up like this. These two planes are now going to interact a bit differently. In fact, if I take these two planes, they touch in exactly one line. There would be one line along which these two planes interact. So I now have a line at which they interact. If, on the other hand, I have yet a third plane, those two interact at a straight line. These two interact at a straight line. But for all three of them to come together, there's only one place where the green, the yellow, and the brown all touch. And that's going to be at a single point, and that point is going to be, in essence, right there. That's where everything comes together in a single point. Now, I could also have planes that are parallel, planes that are parallel that never touch. But if I have one plane that is not parallel, it will at least touch both of the other planes. Regardless of how I do it, it's going to touch both planes, intersect them at a straight line. I could also have three planes that are not parallel, but do touch with each other. So in this case, they are all interacting and each intersects, but no three interact with each other. So this becomes the basis of some three-dimensional Euclidean geometry. And of course, as always, it all collapses if you're not careful. So this is nothing more than an example of some planes and how to work with them.